Welcome to the Virginia Education Center for Asphalt Technology. This is the Asphalt Field Level 2 class, and we're doing the module for density testing, specifically talking about test sections in this module today. Learning objectives for this module are to understand and apply the density testing requirements for standard paving operations. Earlier on in the overview, we talked a little bit about the different types of methods, such as the Method A or the Method B approach. In this module, we're going to go down in the specifics of how each one of those is carried out, and we'll take each step all the way down to filling out each and every form. Method A approach, again, is that cores and plugs. It's accepted based off the cores and plugs compared against maximum theoretical density, whereas Method B is that nuclear gauge that you actually use to compare against the target from your control strip. And we'll go through each step of that. As noted earlier, you've gone through each step of this now. We've gone through an overview. We've talked about the actual roller patterns that have to occur. We've talked about the control strip that has to occur. Both of those occur no matter what method is used. Now we're going to specifically talk about establishing those test sections so that we can determine the average density of those test sections. And then ultimately, is it acceptable? Is the acceptance of that test method or that lot specifically for the paving operation that you're doing at that time, and it has pay adjustments just like everything else. So let's talk a little bit about the overall process. We've talked a little bit about each one of these. You've gone through the steps necessary for a roller pattern. You've determined that optimum peak density and the number of passes by the roller equipment that you're utilizing on that operation that's required to achieve that peak density. That's the roller pattern. And then you had your control strip. You got a target density from that control strip, which was ultimately verified with cores. So now you've got the number of passes necessary to achieve the density based on all the conditions and equipment you have, and you've verified that you actually are getting that density with that under those conditions. So now we're going to talk about the actual test sections in more detail. So we're going to talk about both Method A and Method B, both of which are set up in the same size lots and sublots. So the benefit there is you'll recognize that you use the same lot system and the same sublot system, whether you're using Method A or you're using Method B. However, as this slide depicts, the number of tests that are required does vary. For Method A, your cores, you'll see in the orange there's 1 per sublot. For Method B, nuclear, there's actually 2 tests taken for each sublot, and we'll go into that in more detail. So let's talk about Method A, that core and plug. We're comparing now against maximum theoretical, and test locations are set up stratified random. And we'll talk about what stratified random means. Both methods actually use this, but test Method A also uses stratified random method for determining the location of each test. And each test is divided into sublots. Again, we talked about that in the overview. You'll have a standard lot of about 5,000 feet. That's broken down into equal sublots. So if you have a 5,000 foot lot, you're going to break that down into sublots. So those will be 1,000 feet each, and you'll have 5 of those if you had a 5,000 foot lot. That can vary, and it will vary between 3,000 feet and 7,000 feet. And recognize, again, you can modify that typically sometimes up to 7,500 feet with 5 equal sublots of 1,500 feet if you have enough paving. So if you have a lot of paving going on, again, you get VDOT to allow it, and you can increase the size of your lots and your sublots. But at the end of the day, 1 core is taken from each sublot, and that's separate from your nuclear gauge. So you'll recognize in Method A that you're actually still performing nuclear testing, and I'll talk a little bit more about that as we go through this module. But for Method A, your acceptance is based off cores, but you are still running nuclear density tests as a quality control measure to ensure that you're continuing to get density before you actually take that core. And you can make an adjustment. So if you're taking a nuclear test and you see things are going down, you actually have the ability to adjust that even before you take a core to determine whether or not it's acceptable. All those cores that are taken, though, for Method A have to be bulked in the field. So you will have all the equipment necessary to weigh all your cores right there in the field. And unless you have specific approval and it's close by, you don't take those back to a laboratory. You actually bulk them and run them in the field. And that's compared to your daily RICE, your GMM. It's used as a basis to determine your percent density. And you'll get that from your laboratory. We'll talk about that again. So here's a slide that depicts what a lot might look like. You might have a 5,000 foot lot, and that's broken down into 1,000-foot sublots. It's a random process, and it's designed to guard against bias. So for example, if you didn't have that, you could actually, if you didn't randomize that, you could actually run all your tests in that first 500 to 1,000 feet, and then you may have another 4,500 to 4,000 feet that's not tested at all. So the process is designed to actually randomize that and to stratify that in such a way that now you're actually breaking each section down to where it has an equal chance of being selected. So as I said before, your lots are 5,000 feet as a standard size lot. Sublot standard size is 1,000 feet. You now have an equal chance to actually get tests throughout that full length of 5,000 feet. And that stratification is required to break it down into separate but equal parts. So you'll have a separate sublot of 1,000 feet, and for method A, you're going to take a core out of each one of those sublots. And we'll go into this in more detail, particularly when we actually start running through the TL59A that you have to fill out when you're running the testing for this. That randomization is a standard randomization process. There are many ways to achieve that. Most phones on them today, you can actually have an app on there that'll give you random numbers, and you can select it that way. For purposes of this exam, and in many instances, many of the contractors utilize forms that actually have randomization numbers already created on those, and they're actually created in a way similar to what you see on this slide. So for example, you'll see in the far left, it says distance from the beginning of the sublot, or distance from sublot start. And there will be random numbers under that test section. Those numbers were created randomly. And then on the right side, you'll see a paving width. So you may be paving anywhere from 8 feet in this case, all the way up to 14 feet. So if you have a section, let's just say is 12 feet wide, which would be typical, then you see a random series of numbers that is your distance from your reference line. And I'll show you what that looks like. So for the first one, this random chart told us that our first test in our first sublot is 437 feet from the beginning of that sublot. And our section is 12 feet wide, so we go over to the right, we go down to that same line, and we see that our offset is now 3 feet from our edge line, from our reference line. Now, one thing to keep in mind is you must keep that reference line consistent. So if you start as your reference line is on your right, like you see here, you must keep it that way throughout the paving operation. You can't obviously change over to the left side because now there's no commonality to where each one of those is from, and you can get lost as to where the test may or may not be. So the reference should always be from the right or from the left, but you can't mix those two up. You go down to your next test, you're now in your second sublot. The random number was 226, so you move in 226 feet from the beginning of that sublot. Your offset in this case at 12 foot wide paving width is 5 feet. So you just come in from your reference line, in this case from the right, 5 feet, and you now have your test section location for sublot 2. And you just carry that out throughout this lot. So in this case we have 5 sublots. You'll see that we have 5 tests that are randomized based on this random chart. For purposes of the exam, you'll see a chart very similar to this. So when you do take your exam, you will be given the randomization chart. You won't have to try to create your own random numbers, obviously. But this will be given to you, and it'll look very similar to what you see in this slide. So now, you got to take your core, and it has to be either wet cored. It's allowed to be wet cored if it's a base mix. However, if it's a surface mix or an intermediate mix, it must be dry cored. And you ask why? Why can't we do a wet core on our surface? Well, it takes too long to dry that core out, and you wouldn't get your results until after your paving operation is complete, and then you wouldn't be able to make any adjustments necessary. With base mix, they're a little bit bigger, a little bit heavier. It's harder to get a dry core out of those accurately, so we must wet core those in most cases, so that we can actually get an accurate core. But again, for surface and intermediate mixes, they must be dry cored. Spoke about this in the overview at the very beginning. keep in mind that there's no testing for surface and intermediate mixes within 12 inches of that edge. So all the tests have to be outside of that 12 inches. And then same thing for base mixes, but it's now 18 inches. So for base mixes, you must move in 18 inches. You ask the question, what if my random number says that I have to run the test at 8 inches? Well, then you have to offset that to the 12-inch mark, and then you make a note that the reason why you actually made that adjustment. Spoke earlier about longitudinal joint testing. Longitudinal joint testing is required whether you're using method A, and we'll talk for here, or when we talk about method B, we'll talk about it again. But longitudinal joint testing is required, and it must be greater than or equal to 95% of that control strip target. You're going to be running your longitudinal joint testing with that nuclear gauge, so you'll always have the nuclear gauge on site. As I spoke to you earlier about method A, you're running nuclear tests and cores. The cores are just used for acceptance. The nuclear tests are used for quality control and for longitudinal joint testing like we're talking about here. And in the case of longitudinal joints, keep in mind and remember that you have to do those 4 inches from the joint for surface and intermediate mixes, and it must be 6 inches off the joint for base mixes. So those actually are run at the joint, whereas the test section, sublot tests are actually run off the joint. That's why you have to run a separate test, and it has a separate requirement. Here's the pay table, table 3-4A. This is for surface, intermediate, and base mixes. You'll see again that if you got greater than 95.5% on surface and intermediate mixes, you have a deduct of 5%. You only get 95% of your pay. For base mixes, you'll see there's a note that range for 100% pay actually goes up to 97% of maximum theoretical in this case. So you can actually go up to 97% and still get 100% pay on base mixes. For surface and intermediate mixes, again, to get 100% pay, you're between 92.5 and 96.5. And the same rules applies as you go down that list. You get deducts on your pay all the way down to if you're less than 88%, it's actually remove and replace. You'll have to repave that section, and then that is at no cost to the department. So here's that form that I talked about, Form TL59A. TL59A is the form that's utilized when you're running cores for acceptance of your density testing. We talked to you earlier about where method A is utilized. So keep in mind, that's the 2,000, greater than 2,000 vehicles a day. It has to be at least 20 feet wide. Now you're out there doing your lot testing, and here's what the form specifically looks like. And it has all the data that you need on it to run your test. You will be filling this out when you're actually running tests in the field. For the exam, you'll see a form very similar to this. The data will already be on the form because obviously you can't do that during the exam. You're not going to be running specific tests, so that data will be provided in a form very similar to what you see in this slide. The top of that TL59A, it's all that project and mix description type data. It talks about what date you're actually out there paving. So that needs to be on there, and it has to be accurate. You have to actually state the date that you're doing the paving, obviously. Which lot you're in. In this case, you'll see that you're in lot number 2. That's very critical, particularly as we start running our sublot tests below. And then the paving length, the actual mix type. The mix type is very critical because that determines your pay, right? So it tells you which type of mix I'm utilizing, so I know how it's going to be paid for. And then you'll have things like the application width. You've got to have the application width, as you noted a minute ago, to determine what that randomization for your distance and offset for each sublot test is. So all this data will be provided at the top of that TL59A. You will fill that out when you're actually out there paving and performing this testing. It will be provided for you on the exam. The next portion of that is that control strip information. We talked to you about how a control strip is developed and all the data that comes from that and how it's utilized. You will transfer that information from that control strip to this form. And you'll see on there that there's a control strip date and number, so it tells you when that control strip, it's the first control strip in this instance that occurred, and it was done on the very same day as your paving. It's done on June the 6th of 2013 is what this form shows. And you have the target density there. So that's the density that was achieved in that control strip. And in this case, it was 141.4. And then you put a serial number for the nuclear gauge that you're using, because keep in mind that if something happens and you have to change the actual nuclear gauge that created that roller pattern and control strip, you have to go back and create a new roller pattern and control strip with that new gauge. So you have to have that information so that you can ensure that that gauge is the one that's continuing to be utilized. Then you have a minimum longitudinal joint density. We talked about the requirements for longitudinal joint density. That's 95% of that control strip density. So in this case, that's 134.3. 134.3 is 95% of 141.4. You'll put that on the form as well as your daily GMM. So here on June the 21st, you've contacted your laboratory and said, okay, what's my daily GMM for today? And you'll write that on the form. In this case, it's 2.424. And you put on the end there, that's your lot number. Again, you got lot number 2 here, and which samples that GMM came from. Now, the important parts. You start actually performing the actual tests going down the road, and you're actually doing your sublots. You'll see in this instance, and this is a highly recommended practice, that the first number that you have on there, that 2, is actually the lot that you're in. So in this case, at the top of the form, it said that we're in test section number 2. So that's why on the sublots, you'll see that first number is always a 2 for lot number 2. So for the sublots, though, you're going to break that down by letter. So in this case, we did A, B, C, D, and E. We had a 5,000-foot lot with 1,000-foot sublots. So we have 5 of those. And then you just start working your way across. We had that random generation table that we utilized earlier to kind of get those numbers that we need to figure out exactly where each and every one of those tests have to be. And we pulled each one of those from that random number generator table for a 12-foot wide width. Again, that first test was at 437 feet in from the beginning of the sublot, and it had an offset of 3 feet. In this case, we did it from the right, so that we measured each one of those from the same reference point. And we just went right down the line and pulled those numbers straight off that chart. You will do the same thing on your exam. If you utilize charts like this in the field, this is the way you will actually determine that random generation. You can use random generators off of your phone or anywhere else. VDOT does not specifically require a specific type of random generator. Again, though, for the exam, this information will be provided. From there, you're going to have your cores that you're actually going to start weighing. Remember, you have to have that bulk equipment in the field, so it'll be there in your vehicle, and you'll actually start weighing each one of those. You'll get a weight in air at the very beginning of those, and you'll follow this chart all the way down and start filling out the chart just as it's stated. So you'll see the weight in air, that's just a straight weight. And you'll see, like for sublot 2A, it was 225.5. And you did that weight in air for each and every one of those cores. From there, you also took that and you get a weight in water. So you actually put it in the bulk bucket, and you actually got a weight in water. And then you pulled that out and you got a saturated surface damp weight as well. And so all those weights that are on there, you've calculated in the field with the scales that you have in the field on your vehicle, and you've filled out this form. One thing to always keep in mind is to check your numbers. If you see that your SSD weight is actually lower than your weight in air, then you know you've made a mistake. Something's gone wrong, something's not right, and you need to stop and start over or fix that, because obviously the SSD weight has to be greater than your weight in air, because now you have water included in your weight. You'll have your volume that you have to calculate. And the form is very helpful because it actually tells you that you just take column C and you subtract column B. And that's exactly what you see over there on the right. And you'll see that the volume for, let's say, sublot 2B was 536.3. So we took 1,270.4 and we subtracted 734.1. And we got 536.3. That was the volume that we calculated from our testing. And we do that for each and every sublot core that we're testing. From there, we calculate the GMB. So that's your bulk gravity, and that takes your weight in air, and you divide that volume that you just calculated from the weight in air, and that gives you the GMB. So you do that for each and every one of those. Let's just say for sublot 2D, we had 1257.6 divided by 546.9, and that gave us 2.3. So we had a GMB in that case of 2.3. And we do that for each and every sublot core as we go along. We test each one of those, and we'll get that GMB as we go. We have to average all of those. So we will take an average of that number, and we'll get an average. In this case, we took all 5 of those, and we averaged, and we got 2.280. And that information is utilized to calculate your percent of GMM. So now you're getting to the point to where you're determining, are these going to be acceptable? Are we going to meet the specifications? And to get the percent GMM, you just take your GMB, you divide it by your daily GMM. So you see it circled up there as the daily GMM was 2.424. So you take 2.27, divide that by 2.424, multiply it by 100 to get it into a percentage, and now we have 93.6% of GMM. So we see that in our first case, we had 93.6. We carry that process down through each and every one of those sublot cores, and we average that at the bottom. We've got an average of all of those of 94.1. So you take that step, and now you've determined what your percent GMM is for each one of your sublots, and the average is for your entire lot. Now we got to compare it to our specifications. We got to say, okay, now that I got this data, am I passing? Does each one of my sublots pass, and then does my overall lot pass? We showed you earlier the table that talked about to get 100% pay, we need to be at 92.5 to 96.5. In this case, we had an SM 9.5, so our acceptance criteria for 100% pay is 92.5 to 96.5. And we just compare each one of those sublots to those requirements. And you will see as we walk down through this that each one of those passed with the exception of the last one. The last one was 92.0. That's outside of our 100% pay requirement. And you ask, why is this important? If you remember, we have a bonus criteria when we're using method A. If you have 80% of your lots that pass and you have 100% of your average meets the 100% requirement, then now you can get a bonus. So in this case, we actually had 4 of our 5 sublots that passed that requirement. So we meet the 80% requirement. And our average was 94.1. It's also within that 92.5 to 96.5. So yes, this is bonus eligible. So it's acceptable, right? So now we have a lot and a sublot that meets the requirements and will actually achieve a bonus. We got one more step though. We got to look at that longitudinal joint density, right? If you remember correctly, up at the top of the form, we actually put it on there. We have a minimum joint density that was 95% of our control strip density. In this instance, that was 134.3. In this case on the exam again, the longitudinal joint data will actually be provided to you. That was done with a nuclear gauge within those requirements that we showed you earlier about longitudinal joint testing. And you'll actually take those numbers and you must now compare each one of those numbers to that minimum longitudinal joint density requirement of 134.3. If you look to the right, you'll see all the longitudinal joint testing that occurred. In this case, we had both a left and a right longitudinal joint, and each one of those must be at least 134.3. You'll see in this instance, they are. So all of our longitudinal joints met that requirement. Now I'll remind you, if you remember, if you're going down the road and you actually run a longitudinal joint test and you get multiple longitudinal joint tests that fail, what do? Well, you got to notify VDOT. You got to say, okay, VDOT, we've got multiple longitudinal joint tests that are failing. I'm going to correct that, and here's how I'm going to correct that. Again, we spoke about you may need to actually talk to the roller operator. Maybe they're not getting to the joint as well as they should. Maybe they're missing a few passes on that joint. They're not getting it tied down properly. You need to make sure that you get that done, and you have to report that to VDOT if you don't. But in this specific instance, all of our longitudinal joint tests passed, and we're good to go. So now, I talked to you about again, and we got that same overview. Don't forget, if you look at the very bottom of that slide, you'll see that you have both the nuclear gauge tests as well as the core tests. So if I'm doing method A, where I'm doing cores, not only am I running the cores that are used for acceptance, those are the ones that are critical because I have to be sure that I'm actually meeting the requirements, and I may very well even get a bonus. But for method A, I also have to run the nuclear tests. So I'm actually running both the cores and the nuclear tests. The nuclear tests are purely for quality control, but is required by VDOT. So let's talk about method B now. Method B, again, is that nuclear density gauge process that we use. We're no longer using cores. Again, this is for routes typically that are less than 2,000 vehicles a day and can be any width. In this case, you're now going to be comparing your density back to that control strip target density that you got. We're not using cores, so we're not using that daily GMM or that daily RICE to compare against. We're now comparing against the actual control strip that we created at the very beginning of that process. And to get 100% pay for that, you got to be between 98 and 102% of that target density. Again, anytime you don't meet those requirements, you've got to notify the engineer. So you got to be cognizant of every time you're running these tests. If you're getting failures, you've got to notify VDOT and tell them what that corrective action is that you're taking. And this is the form that's utilized for method B, and it's TL59B. So it's TL59A for method A, TL59B for method B. And it's a little bit different, obviously, because now you're comparing against that control strip density. You'll see the date again at the top and so forth, which control strip this was. You'll have your control strip target, 141.4 again. But now for that 100% pay segment, again, that was 98 to 102% of the control strip. You can go ahead and calculate those and put those at the top of the form. So at 98%, you're at 138.6, and at 102%, we're at 144.2. So that gives us our data that we need to say, okay, to get 100% pay, this is where I need to be. I've got to be between those two numbers. And now you're running your test for your sublots. So you did the same thing that you did earlier for your randomization. You have to go through the process of determining what your distance is, and that's beginning from the beginning of your sublot, and your offset. You do that for each and every one of those. So as you go down the line, you'll see now that we have double the number of tests that we had with our cores. So we have, again, instead of 5 tests, we have 10 tests because we have 2 nuclear density tests per sublot. Now it's pretty straightforward though, because you're running a nuclear density test and you actually do that with each test. So you set the gauge down and you actually perform a test and you write the number down. You do that for each sublot test, and then you average those adjacent to that. So you average each sublot. So you have a sublot 1. The average of sublot 1 was 143.3. Moving on down, let's say you're in sublot 4, and you got 138.0 and 140.8. You average those two together now, and you got 139.4. You do that for all of your sublot tests. And in this case, now you have 5 sublot averages. So you got that, and you average all 5 of those. The average for all 5 of those in this instance was 141.7. For your exam, you'll be given that nuclear density in the column that's there. You'll see that nuclear density column, and that will be provided because you obviously can't go out in the field and actually run a nuclear density test. You'll have to actually fill out that randomization based off the chart that's provided to you in the exam. But again, when you're out in the field, you'll do all of this. You'll have your own randomization. You'll determine what the randomization for your distance and your offset is, and you'll run your nuclear density test and put those in each one of those slots. So now we've got sublots that averaged 141.7. We have to now go down and compare that to our requirements. Again, what did I say it had to be? It's got to be between 98 to 102% of your control strip target density. So let's compare that. We took that 141.7 that we calculated by averaging all 5 of those sublot averages. And so now we had 141.7 as our sublot average. we have to compare that, and we actually wrote that at the top of the page. So now we have 138.6 as our minimum and 144.2 as our maximum. Does it fall between those two numbers? Yes, it does, because our actual percent density in this instance was 100.2. So we're actually acceptable for this lot. We met the requirements for 100% pay. But what else do we need to do? Now we got to go back and look at those longitudinal joint densities. So if you look at that, again, it's the same requirement for all of our nuclear densities. We have to have 95% of our longitudinal joint compared against that control strip target density. So let's look at these. Again, we took one for every single sublot. So now we're out there running our test for longitudinal joints. We have calculations for both our left side in this instance as well as our right side. We compare each one of those to our target control strip density of 141.4. We must meet that 95% requirement, right? So in this case, we did. So now we've met every single one of our requirements for this lot, and it is acceptable. So we've both met the sublot densities for our test sections, as well as our longitudinal joint requirements. So this lot is completely acceptable. One thing to always keep in mind, whether you're using method A or you're using method B, you've got to turn that information in each day. The specifications require that you, for each test section, each lot, that you provide that information to the inspector at the completion of each day's testing. So make sure you accomplish that. So in summary, keep in mind that the test sections are divided into stratified random locations. It's not just random, it's stratified random, and that's why for a 5,000 foot lot, it's stratified into 1,000 foot sublots. So that's the stratification, is that sublot process. Each one is divided into sublots for, say, a 5,000 foot. You may have 1,000 feet. However, you're allowed to go down as low as 3,000 foot for a lot and as high as 7,000 feet for a lot. So on a given day, you may pave only 3,000 feet, but that still will meet the lot requirements, and that becomes a lot because you try to do one new lot for each production day. However, if you do have high quantities of paving that are going on, you can get that modified. And you can modify that up to, say, 7,500 feet with sublots equal to, and in this case, if it was 7,500 feet, you would have a sublot at 1,500 feet. That applies either way, whether it be method A or method B, all those requirements. For method A, though, remember you're using cores for acceptance. So now you're actually taking those cores and you're comparing them back to that average daily GMM, and that gives you your pass-fail criteria, whether or not you meet. However, for method A, you are still running those nuclear density tests for quality control. That is required by VDOT, and you will continue to do that. So you'll actually be running both cores and nuclear density tests, but your acceptance is based off the cores, and that's based off that comparison against your average daily RICE. For nuclear density, it's pretty straightforward. You're comparing those back to your control strip target density. So at the end of the day, each one of those nuclear tests has to meet the requirement for control strip. But remember, both method A as well as method B, you must perform that longitudinal joint testing as well. That has to be recorded. And if you're not meeting those requirements, you have to talk to your inspector and notify the engineer that you're not meeting the requirements and what you're doing to correct that. There's not any pay penalty for longitudinal joints requirements. However, you must notify and take corrective action. Okay, let's practice. So in your books, you have an example problem for Chapter 3, practice problem exercise number 1. So let's go through that problem here today so that you can start getting some practice under your belt. So the first problem is using the random generator table that you have in that slide. Complete the asphalt density acceptance test report for method A. So this is the TL59A form. You're going to get a lane width of 11 feet and your reference line is on the right. So you're going to use this table that's going to be provided to you just like it'll be on the exam. So you'll see this type of table that's provided to you during the exam as well as through this practice problem. You'll have multiple ways again to get the random numbers once you're out in the field, but for the exam purposes and for this example problem, this is your random table. So here's the TL59A. You've got all the information that's being provided to you. You have the top of the form. So the top of the form, it'll tell you the date that you're actually doing the work. It'll tell you things like the lot that you're in. In this case, we're in lot number 2, and the length of that lot is 5,000 feet. So that tells you you're going to have 5 sublots, right? It tells you the calculated tonnage, what type of mix that you're using. In this case, we're using an SM 12.5D. It tells you the location where you're doing the paving, and the important part, like we saw in the example problem, this is an 11-foot wide section that we're paving. Has all that top information that is generic to the work that you're performing, no matter what lot you're in, other than to identify which lot that you're working on at that time. Next thing you need to do is transfer that information that you just got from when you did your roller pattern and control strip. So in this instance, you've got your control strip number and date. So this was control strip based on control strip number 1. And this is September the 15th of 2013 when this one was performed. And you had a control strip density of 148.4. You need to know things like, what's that longitudinal joint density? Don't forget, the lots, you're constantly checking your longitudinal joints as you're performing this testing, and that's 95%. You got to have a minimum of 95% of your control strip density for those longitudinal joints. And you need to have that nuclear gauge serial number so that you can ensure that you're using the same nuclear gauge throughout the testing, because anytime a nuclear gauge changes, you have to do a new roller pattern and control strip. So now let's get down into the meat of this form. So, just like we just told you, you've got that random generator table, and you've got to determine where your stratified random tests are going to occur. We know we're in lot number 2, so that first number in your sublot designation is a 2 in this case. And then from there, we knew we had a 5,000 foot length lot, and we need to divide that down into 5 sublots. So in this case, we've got A through E, so we have 5 sublots. You go over to the table beside it, you'll see that you have the distance from the start, and those numbers are just literally transferred from your random generator table over to your TL59A, and you'll see 437, 226, 611, 402, and 964 as that initial distance that you have in each one of those sublots. Then you go over, in this case, remember, we had 11-foot wide pavement sections. So you're going to pull that 11-foot wide section off, and right below that are all the random numbers for your offset. So now we have a 7, a 3, a 4, a 8, and a 2. We literally just transfer those over into the offset column, and now we have where each one of those tests are supposed to occur in each sublot. From there, you're going to actually start your testing. When you're out in the field, you're going to actually start weighing the cores. TL59A, method A, is all based on cores, so you're going to weigh each and every one of those cores. You're going to weigh them in air, and you're going to go down that line. You're going to weigh them in water, and you'll calculate you'll put all those numbers in that column, and then you'll get your saturated surface damp number, and that's column C. For the purpose of the exam, of course, all that information will be provided to you on a form similar to this, and you'll just calculate the last 2 columns, which is the volume, which is literally column C, which was that saturated surface damp column, minus column B, which was your weight in water, right? And you just simply subtract those 2 numbers, and you'll see that each one of those is filled out at 494.9. The section was also 494.9, all the way down to your last sublot test, which was 2E, and that was 487.8. The next column is your bulk specific gravity, and that, just like it says right at the top of that column, it tells you that you take A and divide that by C minus B. So you're literally just taking those numbers and you're calculating your bulk specific gravity. And you'll see that for the first one, 2A, you got 2.46. All the way down to each one of those, you're just doing that same calculation. And your last one for 2E was 2.42. So now you have a number, a bulk specific gravity for each one of those cores. So what do you do next? Well, you got to determine whether or not each one of those actually passes those requirements. If you remember, to get the bonus, you have to have 80% of your tests pass those requirements. So in this case, we have 5 tests, so at least 4 of those must pass. So you need to calculate that into a percentage, and then you get your percent of your maximum theoretical. In this first case, we had 93%, then we had 93.4, 93.8, 93.0, and the last one was 94.2. So you need to check yourself. Does it meet those requirements for that specific mix? In this case, we're using an SM12.5D. And for each one of those independent tests, they all met the minimum of 92.5. So in this case, each one of those was actually bonus eligible. So 100% of your sublots were bonus eligible. Then you have to just do that calculation to ensure. Certainly in this case, all 5 of them passed. So our actual average bulk gravity was 2.472. You'll see that's carried out to 3 decimal places. So now remember, you're going out to 3 decimal places for the average, because each one of those above was 2 decimal places. When you average those, you'll carry that final answer of 2.472 to 3 decimal places. You calculate your percentage. In this case, it was 93.5. As I said a minute ago, 100% of your samples passed for the sublots, as well as the 93.5 passes for 100% pay. So is this lot bonus eligible? Yes, it is. So you'll see there you have a 5% bonus for this lot. So you get paid 105% for this lot. But what's the last thing you got to do? Well, the last thing we have to do is we have to check those longitudinal joint densities. You're doing that as you're performing each one of those tests. You're actually running a nuclear gauge test for longitudinal joint density testing, and you're checking each one of those as you go. But on this form, at the end of the day, you got to also check to be sure that you didn't miss something, that each one of those longitudinal joint density tests actually passed. What was that? Well, that's 95% of your control strip density, right? In this case, you had to have a minimum longitudinal joint density of 141.0. We wrote that at the top of the form. So now all you have to do is check each one of those. And you go down that list and be sure that each one of those is actually equal to or greater than 141.0. If you look at those 2 columns, you'll see that each and every one of those actually is equal to or greater than 141.0. So all your longitudinal joint testing also passed in this case. So this lot, 100% of all your testing passed these density requirements for method A. So now let's check one for method B. So now method B, remember, that's the one where you're actually using the nuclear density gauge itself. That one requires 2 tests per sublot. And in this case, we're also doing one that's 11 feet wide, and its reference line is also on the right. So remembering that when you're checking these, you also need to make sure that you keep that reference line consistent. So if either you're always from the right or always from the left. So in this case now, you'll see that you have a random number generator table that actually has more numbers, right? So now you're doing 2 tests per sublot. So we need to have at least 10 tests if we have a standard 5,000 foot lot. And here's that form. So now you have a TL59B, and that form is a little different because now you're doing all your testing with the nuclear density gauge. You still have some of that same information that has to be transferred over. Now you must transfer that same control strip density information that you had earlier over to this form. In this case, it was control strip number 1, again, September the 15th of 2023 in this case, and your target density from that control strip was 148.4. So you got that number. Now you also, don't forget, you have longitudinal joint densities. You also have to have, in this instance, your minimum and your maximum for 100% pay. You got to have 98% to 102% of your control strip density. So you can calculate those numbers and put those right at the top of the form. 98% of 148.4 is 145.4, and 102% of that number is 151.4. So now you have your targets sitting right at the top of the form, and all that information is right in front of you as you're going down through your testing. Again, the next step is you got to have that stratified random number for each one of those tests. And that chart was provided to you in this example problem. You take that example problem and you transfer that information over. You'll see that you have a column for the distance again. You just literally transfer those numbers from that column straight to this form. First number being the distance, the last number being your location, and so forth. Last thing we need to do is also transfer that offset. We had an 11-foot wide offset in this instance. So we're going to, in this case, you got an offset for the first one was 2 feet. You continue that all the way down that same column for 11 feet, and you'll see that the last one is 3 feet offset. So you're literally just transferring these numbers from that first to that second column in this instance. So you'll see that the second column is the distance from the sublot start. Transfer all those numbers over to your distance column. Your offsets, transfer those over, and you've got that section done. That tells you where each and every one of those tests must be taken. Now you got your nuclear density testing that you're done. You're going down your test section and you're actually performing those tests with your nuclear density gauge. That's that nuclear density column, and all those numbers are actually placed in there as you're going down the roadway. For the purposes of the exam, that will be given to you, obviously. You won't be able to actually perform that testing, so that column that's titled nuclear density will be provided on the exam, and you'll actually have all those numbers, and then you basically have to average those. Remember, we had 2 tests per sublot, so we need to know what the average was for each sublot. So you literally just take those 2 numbers and you add those 2 together, divide them by 2, and that's how you get that sublot average. And you'll see we went from 148.5 in sublot 1 all the way down to 148.1 in sublot number 5. So now what do we do? We got the same situation. We got to determine, did the sublots pass, and did the actual lot pass? So we look at each and every one of those numbers. We average the sublot averages. So now we take those 5 numbers and we average those. In this instance, we came up with 148.6 is our average for the sublot. 148.6 is actually between the 98 to 102%, right? We had to have 98% as a minimum. That was 145.4. We had to have 102% as a maximum to get 100% pay. That was 151.4. In this case, we had 148.6. So that number falls between the 98 to 102%. So this lot passes for those densities. But are we finished? No, we're not. We still have to check those longitudinal joints. We check the longitudinal joints whether we're using method A or method B. So we got to go down and check each and every one of those. So what was the requirement for longitudinal joints? You got to have 95% minimum of that control strip density. And you just calculate that as 95% of that 148.4, and you compare each and every one of those sublot tests to that requirement. So that, in this instance, you go down through each one of those tests and you determine whether or not it meets those requirements. In this case, they all meet that minimum requirement. So this lot passes. So for exercise number 1, for the TL59B, we have a lot that passes all the requirements again. Now, you've got another problem that you can do. We want you to do that one on your own. You can pause this video and sit down and actually walk through exercise number 2 and do that on your own. And then once you're done, you'll see that the answers to that problem are actually in the back of your book. So all you'll have to do is do the same thing that we just did on exercise number 1, walk through exercise number 2 on your own, and then check it. All those answers, again, are in the back of your manual. So with that, this chapter is complete. So if you have any questions, please see your moderator, and I'm sure they'll be glad to help. Thanks again.